Pause and copy, pause and copy. Find the dimension. So H is this thing. All three-dimensional vectors that have this strange form. Let's try to extract the dimension from this mess. What am I going to do? I'm going to take this thing and rewrite it. It's going to be x times 101 plus. So I just said, okay, there's 1x here, 0x is here, and 1x here. Give me the 101. And for the y, 210. And then for the z, 311. Okay, from this thing in, what is that, pink, purple? From this thing here, I see that H is the span of these three vectors. Okay, everything in H is a linear combination of these three vectors. I need a basis to find dimension. So I want to check, are these three vectors independent? Let's see. So I put them into a matrix and see what there is to see. So I'm going to start reducing, see what happens. If I get three pivots, I will conclude that they are independent. Otherwise, not. So what do I do? First operation is to kill this one here. So subtraction. And then I get 1, 2, 3, 0, 1, 1, 0, 0, 0. So we see that they are not independent. So this is a dependent set. So what else do I notice? Well, I notice from this calculation is that my third vector here is a linear combination of the first two. Okay, so what I'm going to do is just delete this third vector and see what I get. So again, I've determined that the three vectors are dependent, meaning I can subtract one without changing the span. So sometimes it doesn't matter which one you subtract. In this case, it was pretty obvious that it was safe to subtract this one, since from here I can see that this vector is a linear combination of these two. And I know that span B is equal to H. Okay, basically because, what I did here showed me that this vector is sort of extra fat that can be cut off without changing the span. Okay, the span of these three vectors is not changed by deleting this extra one. And I found it was extra over here. So span in B is H. So it's halfway to being a basis. I just have to check that it's an independent set. But I can just look at these two vectors and see that they are not linear combinations of each other. So B is clearly independent. Okay, again, my reasoning is that when I have two non-zero vectors and they are not, and how should I say this carefully, neither one is a linear combination of the other, I can conclude that this set is independent. Okay, so there you have it. B spans H, and B is independent, so it's a basis. So B is a basis, that's why I use the letter B. And there are two elements here. So my dimension of H is equal to 2. Because I found a basis, and that basis had two elements in it.